What do these things have in common? Length, yeah, the distance between 2 points. Speed, how fast something is moving. Time, the interval between two events. Well, all of these things I just mentioned, length, time, distance, they are all known as physical quantities. Why do we refer to these things as physical quantities? The answer is simple. They are known as physical quantities because they can be measured. I take that again. They are known as physical quantities because they can be measured. So anything, any property of a material, a system, or a phenomenon that can be quantified through measurement, then that thing becomes a physical quantity. So for example, the mass of an object. The mass of an object can be measured. The speed of a car. The speed of a car can be measured. The distance between 2 points can be measured. The time taken to complete a particular assignment can be measured. So the fact that we can measure all of these things means that they are known as physical quantities. So physical quantities refers to properties of material, system, or phenomenon that can be quantified through measurement. So I think that is clear, right? And we've already looked at some examples of physical quantities like length, mass, distance, time, speed. All of these are physical quantities. When it comes to physics, physical quantities can be a group based on certain criteria. We can group them based on their origin or based on their directional properties. When referred to classifying physical quantities based on their origin, that's when we have a derived unit and basic unit. For this lesson, we'll not be talking so much about that. That will be for a different lesson. But it will be focusing rather on the type of classification that divides physical quantities based on their directional properties. So that's what we'll be discussing in this lesson. And when it comes to dividing or classifying physical quantities based on their directional properties, we have two types. And what are those? We have vector quantities and scalar quantities. Vector quantities are what? And scalar quantities. We'll be taking them one after the other. And by the end of this lesson, hopefully it will make sense to you. Yes. So let's pick the first one, scalar quantities. What exactly are scalar quantities? For scalar quantities, I'll use an example to explain what it is. So suppose somebody asks you that maybe you are driving, like this man driving so much. Somebody asks you, the driver, that what is the speed of the car you are driving? At what speed are you driving? So this driver, at what speed is he driving? In the driver's seat, there is a speedometer in front. Just as you can see, all the speedometer reads. So the next time you sit in the car, check the speedometer. The speedometer tells you the speed at which the car is moving. So maybe the car is moving at 60 kilometers per hour or 100 kilometers per hour. What that means is that in every 1 hour, the car travels maybe 60 kilometers. That's the meaning of 60 kilometers per hour. That value that you are seeing on the speedometer is known as the speed of the car. That is why it is called speedometer. That is the speed of the car. You can see that that speed is a value like 60 kilometers per hour. It tells you how fast the car is moving. It doesn't give you any extra information. So what do we mean by a scalar quantity using speed? A scalar quantity is basically a type of quantity that gives you the size of the unit or the size of the material you are measuring without giving you any sense of direction. I'm sure when it comes to scalar and vector quantities, you will understand that very well when we compare it against the scalar. So let me take that again. Scalar quantities are types of quantities that have magnitude but with no specified direction. So let me use the car analogy again, and perhaps that will make more sense. So you are driving a car, and the car has a stated speed on the speedometer. And on the speedometer, you see 60 kilometers per hour. That 60 kilometers per hour is the speed of the car. Now, the next question somebody will ask is, okay, so you are driving to maybe Kufuridua or Takrady or any town of your choice. And the person asks you what is your speed, and just say 60 kilometers per hour. That value is the speed of the car, and it's a scalar quantity. And it's a scalar quantity because it tells you the speed at which you are moving, the size of how fast you are moving, but it doesn't tell us the direction in which you are moving. Now let's compare it against the next unit, which is the vector quantity. We are discussing scalar and vector quantity. For vector quantity, suppose when the person asks you, how fast are you moving? And then instead of just telling the person your speed, you went ahead by telling the person, okay, I'm driving at 60 kilometers per hour due north, or I am driving at 60 kilometers per hour due south. In that case, the 60 kilometers per hour is the speed at which you are driving. Then the due north or due south or due whatever direction refers to the direction at which you are moving. So I take that again. Somebody asks you, "Oh, Kofi, what speed? The car you are driving, what speed at which you are moving?" And he said, okay, I'm driving at 60 kilometers per hour due north. The 60 kilometers is the speed at which you are moving. The due north is the direction at which you are moving. So wherever or whenever you give the size of the unit and then the direction at which you are moving, there is no more a scalar quantity. It becomes a vector quantity. So, for example, this speed analogy I'm using, a speed plus a stated direction becomes a vector quantity. And in that case, it's no more called speed, it's called velocity. So, velocity is basically referring to how fast an object is moving in a specified direction. I take that again. Velocity refers to how fast an object is moving in a specified direction. Meanwhile, speed refers to how fast an object is moving. Finish. So speed is a scalar quantity and velocity is a vector quantity. So what exactly are vector quantities? So vector quantities are quantities that have magnitude and direction. I take that again. Vector quantities are quantities that have magnitude, which is basically the size, and then the direction. So, for example, if somebody says a car is moving at 60 kilometers per hour due north, the 60 kilometers is the magnitude, and due north is the direction. That makes the whole measurement a vector quantity. And a scalar quantity has only magnitude but doesn't have direction. For example, the person is driving the car at a speed of 60 kilometers per hour. Finish. So you don't know whether the person is driving due north, due south, due east, due west. You don't know. So that's basically the difference between scalar quantities and vector quantities. There are so many examples of vector quantity and scalar quantity. Let me get some examples for you really quick. So for scalar quantities, for example, we have mass, distance, speed, volume. For example, the mass of an object is maybe 50 kilograms. Okay, 50 kilograms. It doesn't have any direction attached to it. It's just a size of a measurement. And then distance. It said the distance between 2 points is maybe 5 kilometers. 5 kilometers is a distance. It doesn't tell you the direction. So that makes it a scalar quantity. The same thing applies to speed. But for vector quantities, example, we have velocity. Velocity is speed with direction. Yeah. Then force is also an example of a vector quantity. So you can apply force to an object in a particular direction. So you push the object in a particular direction. That makes it a vector quantity. They also have acceleration, displacement. These are some examples of vector quantities. So there are a lot of examples of vector quantities out there. Which other examples do you know? Write it in the comment section. If you find this lesson helpful and you think you've learned something new from this lesson, well, give it a thumbs up, subscribe to the channel, and see you in our next lesson. In our next lesson, we'll be looking at resolution of vectors. Resolution of vectors. So see you in our next lesson.